The Curl Up and Dye Salon Case Study.
Pinky Shears is the proud proprietor of the Curl Up and Dye neighborhood hair and beauty salon. As Pinky's reputation has grown in the community, she's had to hire more estheticians, and she needs to move beyond managing her employees, customers, services, and appointments out of little boxes of 3x5 index cards and the free appointment calendar given to her by her realtor friend. Pinky's client and friend of many years, computer science professor Craig Z. Hare, agrees to help out by acting as database analyst DBA to do the initial database design and convert her manual record-keeping system to the database. The DBA's first steps are to gather samples of the physical business records Pinky keeps, then to interview her to learn about her business processes and the way that information flows within her business. He will also be keeping an eye out for data, processes, and business rules that Pinky and her employees might keep in their head, which aren't reflected in the data forms and documents he can physically collect.
Here is what the good professor has learned so far. Pinky keeps records of her customers in a box of 3x5 index cards filed alphabetically by the customer's last name. An example appears below. Pinky also allows some customers to run a tab. She updates the current balance for these customers on the customer's contact card, simply crossing out an old balance and writing down the new balance when new charges are made or when a payment is received. Pinky admits she and her bookkeeper need to improve her accounting practice, but for now she just wants to perpetuate the old practice in the new database in order to keep things simple and to get started on a database system more quickly. Pinky manages her esthetician employees in a similarly simple way. A 3x5 index card box with each esthetician's name and address, filed alphabetically by the esthetician's last name. Her bookkeeper manages payroll, so for now that won't be part of the new database system, just the roster of estheticians and their contact information. An example of an esthetician's 3x5 index card record appears below.
Pinky charges for services using the base price listed on her menu of services. This is the basic or minimum price for the service listed. Estheticians advise clients at the time of service of additional expenses based on how complex and extensive additional work requested by the client might be. Thus, the actual total charge for an appointment is often more than the base charge. But since this is handled at the point of sale, cash register, and only concerns the new database system, in the event Pinky approves the customer running a tab, in which case the charge for an appointment is added to the customer's outstanding balance, the database system will not be concerned with these details. A copy of the Curl Up and Dye menu of services appears below. The final document that Professor Hare collected from Pinky is a copy of her appointment calendar. The current paper-based appointment book records the customer's name, the esthetician's name, and the name of the service to be performed, along with the start time of the appointment and the date. Professor Cray learns that scheduling is done either by Pinky or her part-time receptionist, who is also a part-time esthetician and longtime friend of Pinky, and that they know how much time to allot for each appointment based more on the customer's specific request when booking the appointment rather than some standard time allotment associated with the service. Pinky and her estheticians are adamant on this point. The appointment duration depends on the customer's individual desires and the time each individual esthetician estimates to address these, rather than on some standard time for any base service. Pinky's one request involving this is that the esthetician be able to specify the appointment duration in minutes so that the system could be used to determine the expected end time of the appointment. For one thing, this could make rescheduling easier in future, since the system could calculate the end time for an appointment automatically when a start time is moved, so that the user only needs enter the start time and not the end time as well. Professor Cray made a note to add an integer field to the appointment entity to record the appointment duration. A sample page from the curl up and die appointment calendar appears below.
Reviewing the collected documents and notes from interviewing Pinky and her staff, Professor Hare reflected on the genius and flexibility of Relational Database Management System's ability to model databases on real-world entities, as well as Pinky's business acumen in implementing a paper-based record-keeping system that is largely logical and efficient. Hare envisions 4 database entities tables, which will replicate nearly identically the 4 real-world entities Pinky has been using. A customer table will replace Pinky's customer index card file box. An esthetician table will replace Pinky's esthetician index card file box. A service table will record the service description and base price data found on the curl up and die services menu. And an appointment table will replace Pinky's appointment calendar. Professor Hare next reasoned through the relationships between these entities, making the following notes. A customer makes 1 or more appointments. An appointment has exactly 1 customer. An esthetician makes 1 or more appointments. An appointment has exactly 1 esthetician. A specific service is performed at 1 or more appointments. At an appointment, exactly 1 service is performed.
Pinky was at first concerned by Professor Hare's reasoning and pointed out that a customer might be sitting in a salon chair while receiving a pedicure, manicure, and facial simultaneously from 3 different estheticians. Professor Hare pointed out that this is just fine, as there are 3 appointments occurring at the same time. Pinky was amused to observe that this is perfectly possible for a customer who can have several estheticians working on them at once, but that one esthetician can't really deliver 2 appointments at the same time. They agreed that Pinky's scheduling can avoid that situation for now, but that the database could be programmed with an appointment constraint in future that prevents double booking an esthetician.
Professor Hare then drew a preliminary entity relationship diagram, ERD, to visualize these entities and their relationships.
Pinky initially thought the preliminary ERD very strange because many customers see many estheticians and many estheticians see many customers. Professor Hare agreed that his friend Pinky was correct, but pointed out that the vehicle with which customers and estheticians associate with each other is an appointment, and explained this is one reason the appointment entity is referred to as an associative entity, also known as a bridging table. He also offered this intuitive analogy for understanding why a pair of one-to-many relations, 1 customer to many appointments, and 1 esthetician to many clients, many appointments, is simpler and more efficient than a single many-to-many relations, such as if customers related directly to estheticians and vice versa.
Professor Hare: let's say that you have 10 customers and 10 estheticians, and let's assume that every added possible relationship imposes a cost. Call it a complexity tax. 10 customers, each having a relationship with up to 10 different estheticians, is equal to 10 times 10 equals 100 possible relations. Let's call that a complexity index of 100. However, a pair of one-to-many relations, such as 1 customer having 1 appointment with any of 10 estheticians, and 1 esthetician being scheduled for any of 10 appointments with 1 customer, is 2 sets of 1 times 10. And 2 times 1 times 10 equals 20, or a complexity index of 20. So, for a database size of 10 customers and 10 estheticians, using a bridging table gives us a complexity of 20, where a many-to-many relation yields a complexity 500% higher, 100. And the situation quickly gets worse. Imagine we had 1,000 customers and 1,000 estheticians.
Pinky restrained herself from pointing out that one salon employing 1,000 estheticians would be ridiculous, as she knew there was no stopping her old friend once he had that professorial lecture gleam in his eyes.
1,000 times 1,000 is a complexity of 1,000,000, Hare exclaimed. Yet, with an associative entity, the complexity is merely 2 times 1 times 1,000 or 2,000. That is 500 times more efficient.
Pinky kindly made her old friend a nice cup of chamomile tea to enjoy, while his pulse and respiration returned to normal. "What's next?" said Pinky some minutes later. What came next, as it turned out, was a great deal of fussing over details, as Pinky put it. First, Professor Hare made plans to change some details of how Pinky arranged her data. For example, Hare insisted that instead of storing customer names as a single attribute, last name, first name, such as Fisher, Theodore, that this attribute be decomposed into 2 separate attributes, custal name and cust F name. He pointed out that
making the attributes atomic,
as he called it, would be more flexible, such as if you wanted to print mailing labels or personalized form letters or billings to clients. You could easily do this if the first and last name were separate elements, without having to do additional processing each time to separate out the first name. He also broke apart the customer's address, which Pinky's index card system had lumped into one line, such as 10950 Decorah Drive, Sylmar, California, 91406. Customer address, city, state, and zip code each became a separate attribute. Hare pointed out that this would make it easier to sort and filter by these criteria individually. For example, with cust address, cust city, cust state, and cust zip as separate attributes, filtering a list of only customers with addresses in zip code 91406 would be very easy. Professor Hare referred to this as being part of a normalization process, which he insisted was essential to proper and efficient database design and good data integrity. Professor Hare was also very picky about the data types and sizes he selected for each attribute. He explained, for example, that not only must the customer account balance be stored as a numeric data type, for if it were a text type, you could not easily add purchases to it, nor subtract payments from it, but that the data type mattered since money in the United States is only tracked to the nearest cent, which is to say 2 decimal places. For example, 0.01 is a penny, and we don't, at least in beauty salon accounting, need a precision of more than 2 decimal places. So using a higher precision numeric data type than necessary is wasteful, since those data types also require more computer storage to represent. Pinky also overheard Hare muttering arcane facts to himself as he worked, such as
99% of U.S. surnames are shorter than 13 characters. Okay, let's make it 15 characters for good measure.
And similar remarks. Clearly, her friend put a lot of thought into database design.
Professor Hare also added one new attribute to the customer table, unique, non-null integer value that he called a primary key, whose job was to act as a unique identifier for each customer record, since 2 different customers could have identical names, such as Pat Smith. Hare explained that, even though it might be possible to use a combination of other attributes to make a unique key, doing it that way would be 1, less efficient, and 2, more prone to needing to be updated because a data value changed, such as using the address as part of the key. He also noted that using an integer data type for the primary key was useful because integer data types are more efficient to sort than some other data types. Soon, Professor Hare presented Pinky with a completed ERD of his proposed finished database design. The same entities, tables, that appeared in the preliminary design were still there, but now the entities showed the names and data types of each entity's attributes, fields. Professor Hare also provided what he called mock-up data for 3 sample rows in each of the planned tables. Pinky studied Professor Hare's ERD and sample data with an expert managerial eye for several minutes.
I can see how the appointment table works now, said Pinky. Appointment number 27 links on the customer ID, 1011. So looking at the customer table, I see that this appointment is for customer James Hamer. Similarly, I see that the service ID for appointment number 27 is 92507. Looking that link up in the services table, I see that James is going to have his hair colored. I can also see in the appointment sample data that appointment number 29 is with esthetician ID 204. And the esthetician table shows me that esthetician is Stephen Wilson. By linking the tables together using these key values, I see that we don't have to have copies of the entire customer record, plus the entire service menu, plus the entire esthetician record duplicated everywhere. This is much more efficient. If I need to update a customer address, I just change it once in the customer table. I don't have to worry about making that change in one place because there are so many copies of the record. Now there's only one.
Exactly, said Professor Hare. You understand perfectly, Pinky.
One concern Pinky expressed is that none of the service-based prices or the customer balances were formatted as currency. Professor Hare explained that when a field value will always have fixed characters in fixed positions, it would be wasteful to store those characters in the database, and that instead you simply format the value as desired when you display it. Quickly typing in a few commands into his laptop computer, Professor Hare showed Pinky the same information from the sample customer table, but with the customer's balance formatted as U.S. currency.
The difference here, Hare explained, is that the customer balance data has been formatted for display. The underlying data in the database hasn't changed. It still doesn't have the $sign stored as part of the data. We just add that in for show when we want to print or display the values using that format. This keeps the stored data as compact and efficient as possible.
Oh, exclaimed Pinky. That means when you store a phone number like 800-555-1212, you don't actually store the parentheses or the space or the dash. You actually just store 8,555,112. But decorate the data when you want to print it or display it.
Decorate it? Mused Professor Hare. Yes, we decorate it. We call that formatting the data, but decorating is an apt expression, Hare agreed.
With Pinky's approval, Professor Hare then migrated the remaining data from Curl Up and Die's paper record system into the Salon database, and Pinky Shear's database adventure was well and truly begun.